All right, guys. Are there any questions over the previous homework assignment?
If I'm being honest, I never read it.
Any questions over the previous homework assignment? All right, guys, so what we're looking at first and what we're continuing on with are these rational exponents and our radicals. Now, a to the m over m can be rewritten as a to the 1 over m, n to the m, guys, which is the same as the nth root of a to the m. We can do the same thing with a to the negative m over m. Because to make the exponent positive, we move it from the numerator to the denominator. With this here, so to make a exponent positive, we move it from the numerator to the denominator, or denominator to the numerator. Move it from the top of the fraction to the bottom, or bottom to the top, guys. Then we can rewrite it as a to the 1 over n to the m, which is the same as the 1 over the nth root of a to the m. And it makes it easier to simplify or solve. So if we look at these first two here, 16 to the 3/2, guys, we can use the fact that a to the m over n is the same as the nth root of a to the mth power. And for us here, for this problem, a, in our case, is 16, m is 3, and n is 2. So for us here, we can rewrite this as 16 in place of a, n is 2, and the exponent outside the parentheses would be 3. And we can simplify from the inside out. So the first thing we can do is take the square root of 16. And the square root of 16 is 4, guys, to the third. And then from here we can take 4 to the third power, which is 64. Is 16. 4 times 4 is 16. Questions on any of this here? Now for the other one, a 32 to the negative 3/5 is the same as our a to the negative m over n. Now this can be rewritten as 1 over the nth root of a to the mth power. And for this one here, our a is 32. Our m is 3 and n is 5. And if we rewrite this so that we can simplify, we're going to have 1 over parentheses and we get this here because we replace n with 5, a with 32, and m with 3. Now the first thing we need to do is take the 5th root of 32. Now if we did this by hand, we can do the factor tree. Start off with 2 times 16 and break this down from here because 16 is going to be 2 times 8. 8, guys, is 2 times 4, and 4 is 2 times 2. So since we have 2 5 times, the 5th root of 32 is indeed 2. And if we cubed 2, we get 8, guys. So 32 to the negative 3/5 works out to be 1/8. Now for these here, because we do have nice numbers, we can do these in a calculator. So if we look at the first one, 16 to the 3/2, in the calculator we can do 16 to the 3/2. And it'll tell us that it is 64. We could also do 32 to the negative, so here's fifths. And this time we do get a decimal, but in the graphing calculator, if we hit math and then enter, it'll turn it from a decimal to a fraction. Now the 30xs, we can do 32 to the negative 3/5, and it'll tell us that it's 1/8. It'll convert it straight to a fraction for us. So, guys, any questions on this here? Okay. Now, not every radical or every fractional exponent will give us a nice number. So, if we do 9 to the 1/5 in the calculator, we can do 9 to the 1/5, and we get an irrational decimal, but we're taking it to 2 decimal places, which tells us that this is 1.55. Now we can do the same thing with 12 to the 3/8. So we can do 12 to the 3/8 in the calculator. And again, we're rounding it to 2 decimal places, so we'll do 2.54. And again, for the last one, we can just plug this in. So we do parentheses, 4. Our radical, get the 7th root, squared. It's the third. Which gives us 4.30. And since we are rounding to the second decimal place, we do need the 0 there. We need both decimal places. Any questions on any of those here? Now, the other thing we're looking at today is solving these here. To solve an equation of the form u to the n equals d, where u is an algebraic expression, take the nth root of both sides and solve from there. Now, this is very similar to something we've done before. The square root method. Because we did this last semester, we've done this with quadratics. Because if we don't have a middle term, we can get that middle term or the set of parentheses by itself and then take the square root of both sides and solve from there. Here, we're not going to take the square root of both sides. Now, since this first equation we're solving, okay. Now, guys, since we do have a variable, x to the 5th is the only one we have, the first thing we need to do is get it by itself. And what can we do to get it by itself? We would divide both sides by 4. So that would leave us with x to the fifth is equal to 64. Now at this point here, when we were using the square root method, we would square root both sides. So we take the square root of both sides of this equation here. Now would the square root simplify our x to the fifth? No. So instead of taking the square root, we would take the fifth root. Because the fifth root of x to the fifth is indeed going to be x. Right, so we take the fifth root of the left side, fifth root of the right side. Now we need to find the fifth root of 64, which is a decimal. (32). And the fifth root of 32 is 2. So it is 2. Now, what we talked about yesterday with odd roots, because we had 3 cases when we did our a, the nth root of a, and odd roots. If what's inside the odd root was positive, we had 1 real root. If it was 0, we had 1 real root. And if it was negative, we had, well, 1 real root. And since we took the odd root of both sides, x equals 2 is the only real root that we have. And this problem here is only asking for the real solution, so we don't have to find any others. There are 4 other solutions, but they're all complex solutions. They have I. So this here is the only solution. Any questions on this here? Let's look at the next one. Now looking at this one here, we don't have single variable. We have x minus 3 in parentheses to the fourth. Whenever we have a set of parentheses to an exponent and there's no variables anywhere else, we get that set of parentheses by themselves. They already are. So now we can apply a radical to both sides. But we're not going to take the square root, we're going to take the fourth root. Because the fourth root and the fourth power will simplify out, leaving us with x minus 3. Now here we need to see if we can take the fourth root of 21. Because it's going to be a decimal. 2.14. Now since it doesn't ask us to round our answer or simplify that way, we can leave it as the fourth root of 21. But we do need to add a plus or minus, because whenever we take the fourth root or an even root of a positive number, we have to add the plus or minus, because there's 2 cases that we can have. Is the variable by itself, guys? No. So the last thing we need to do is to add 3 to both sides to get x by itself, which tells us x is equal to 3, plus or minus the fourth root of 21. And that's it. Because really the first step is just to get the parentheses or variable with the exponent by itself, then take the root of whatever the exponent is, and then solve from there. So here we have 5x cubed is equal to 320. So the first thing we need to do is get the x cubed by itself. So we would divide by 5. (64). Then we would take the cubed root of both sides. You're good. These would So cubed root of 64 to the 1/3 is 4. And we get this here. So that would be the only root that we have, because again, cubed roots, when we have an odd root, we only have one real root. The other two roots are going to be complex. They're going to be our complex roots. And again, these are only asking for the real solutions. It does not ask for the complex solutions. Any questions on this here? Does anybody know why they call it a cube or cubed roots? Because we call them squares. Well, if we think of a square, has how many dimensions? 2. So if we square something, we're talking about square area, squares. And if we talk about a third dimension, I add 1 to it. What do we have? Cube. So we call it cubed roots, cubics. That's based off a square or a cube. We'll do 2 more of these. Is the set of parentheses that we have here by itself? Yeah, so we would do what? We need to get rid of the exponent first. Because here the 4th root and 4 would cancel out, leaving us with x plus 3 is equal to minus. Now the question is, can we take the 4th root of 24? No, and we could see if there's a number that goes into it that would work, which we break it down using the factor tree. So I always start with 2. 2 times 12 is 24. 12 is 2 and 6 is 2 and 3. We have 3 2s and 1 3, but we need 4 to simplify it. So it just says the 4th root of. And last but not least, we would, guys. So we need the plus or minus on any even roots. So square roots, 4th roots, 6th roots, 8th roots, we need the plus or minus. After we subtract the 3, we have 2 of our real roots. The other 4, or the other 2 roots for this here will be complex. So when we solve these here, we're looking for the real kind of rational or irrational. These here are going to be irrational since the 4th root of 24 does not reduce. It doesn't give us a nice number. We get this here. Questions on any of this here? Now, it's not always going to work out that when we take an even root of both sides that we get this irrational number. Let's just work out on these here. They haven't given us one that does. We'll look at this one here, and then you will have the rest of the time to work on the assignment. 1/2 x to the 5th is equal to 512. So we don't have a set of parentheses, but we do have the one variable to the 5th power. What do we need to do to get rid of the 1/2? We can divide both sides by 1/2, yes? Or what else could we do? By? Because what times 1/2 is 1? Because 2 times 1/2 is 1, yes? So we do 512 times 2. These will cancel. $10.24. Now, if we divided 512 divided by half, we still get. Now, especially on the ACT, doing this here, flipping the fraction and multiplying, can be a little bit nicer, especially when your time's involved. But if you have a calculator, dividing it by the fraction still works well. Either way works. Because if we were doing this by hand and I didn't have a calculator, doing the multiplication of 2 is a little bit easier than trying to divide it by 1/2. Now the last thing we need to do is to take the fifth root of both sides. And we need to take the fifth root of 4. Is 4. And that there would be our only solution. Yeah. So we could do 1/2 of 4 to the 5th. That's 5/12. And again, that's one good way to check to make sure you got the correct answer. We can plug it back in and see what we get. Now, I will show you guys this here. We could do, so fraction, alpha y equals enter, 1/2 x to the 5th was the left side of the equation, yes? The right side of the equation was 5/12. And we can hit graph. So we have the first equation. Now 5/12 was graphed, but again, the basic screen for the graphing calculator is between -10 and 10 for x, and -10 and 10 for y. 5/12 is way off the screen. But we can still do second trace intersection, as we did this on Monday. Now, since there's only going to be one intersection, there's only one place it's going to cross, we can hit enter, 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 and it'll tell us x is 4 when they intersect at the y value of 5/12. And that's a good way to check to make sure you did get the correct answer. That is it. So your assignment is on page 245, 27 through 32, and 36 through 41.